So these are the notes for the second half of 7-7. We did not have enough time last time to cover everything that was in 7-7, but we had a few more things that I needed to let you know so that you'll be able to finish worksheet 7. And so here's what I'm looking at. The things that you need to know are the even, the odd identities. Now, I know this one looks confusing because I have an angle U, but you can think of that as theta, or you can think of that as any angle. It could be sine of x or whatever it may be. You basically know what to do when you switch from a negative angle to a positive angle. If the angle changes from a negative angle into a positive angle, you'll know whether it's going to be the same sign or the opposite sign, depending whether it is even or odd. So the ones that I know that are odd, sine, its cousin, tangent, and its cousin are the odd function. When you see the word odd, I want you to think, man, that's the opposite. That is they do things different. Everything's different. Everything's the opposite of what it started as. Meaning, if it started out as a positive, it turns into a negative. If it started out as a negative, it's going to turn into a positive in front of the function. If it started out as positive, it turns into a negative, or if it starts out as a negative, it turns into a positive. That's what odd functions do. Even functions, on the other hand, when you go from a negative angle into a positive angle, stay the same sign. If it's positive, it stays positive. If it's negative, it stays negative. And its cosine and its cousin secant are the only ones that are even. Now the reason why, if you really, really want to know, the whole even and odd thing is based off of sine and cosine. If I were to draw sine this way, and I were to draw cosine this way, but then I were to go and stretch this line out to the left, and stretch this line out to the left, here's what the deal is. If I stretch this one out to the left, the ones that are even are the ones that you can reflect over the y-axis. This side is the same as this side. Because they're the same, when you rotate them, their signs are going to be the same. But if I were talking about the sine graph, or the tangent graph for that matter, if you try to reflect it, it doesn't work. This side does not match with this side. Where it's a positive here is a negative there. It switches sign. Odd functions change sign when you go from a negative angle to a positive angle. Even functions stay the same sign when they go from a negative angle to a positive angle. I'll explain more as we get into some examples, but that's what it basically is. Let me give you a small example. If I had a function and it says the secant of negative x, the way you would simplify the secant of negative x is you go, that's a negative angle. I want this in terms of a positive angle. You have to decide, is the secant even or odd? It's even. If it's even, it stays the same. This is here's the sign you're checking. It's a positive. It's going to stay a positive. When you go from a negative angle to a positive angle, this is how you simplify it. Let's try one more. Let's say I had the sine of negative x. And I go from a negative angle to a positive angle. I have to decide, is it even or is it odd? Sine is odd. That means whatever sign it is here, I have to do the opposite. It should be negative sine of x. You are always going to write your angles in terms of a positive angle. That's the reason why these things were created, by the way. Okay? You always write your angle in terms of a positive angle. The other things that we're going to do is sometimes you're going to see things like this. The sine of pi over 2 minus theta is equal to cosine of theta. They are so similar to each other, sine and cosine. They're just shifted by pi over 2 or 90 degrees from each other. So, with that being said, I can, if ever I see anything like this, I can go and find which cofunction it is equal to and then simplify it down to whichever cofunction it is. So, we'll use this. I kind of have them sort of memorized. I don't know. These are more lesser used, though, in the big scheme of things. These are not as big of a priority as the Pythagorean identities. If you want to memorize anything, memorize those because you'll use those more often than you would these ones that are right here. So, with that being said, sine is a cofunction with cosine. Cosine is with sine. Secant and cosecant are cofunctions with each other. Tangent and cotangent are cofunctions with each other. So here's how it looks. I have two examples picked out for you, and this is on worksheet 7. If you would like to do this with me, you feel free to do so. I'm going to start with number 16. I'm going to work on the numerator first. It says sine of negative x. Uh-oh, it has a negative angle. I need to switch this to a positive angle, so I know it's going to be a sine of a positive x, but now I need to make a decision. Is this even or is this odd? If you know, tell the person you're sitting next to. If you said odd, you are correct, which means since the value in front is a positive, I'm going to put a little positive sign there. I need to do the opposite. Odds, opposite. That makes this negative sine of x for our numerator. Now our denominator. Sine of pi over 2 minus x. Do not distribute this. Use the cofunction identities. And we just have them right there. I can switch between sine and cosine using the cofunction identities. This is equal to cosine of x using our cofunction identity. If you're unsure why, let's look at this one. The sine of pi over 2x minus theta is equal to the cosine of theta. That's the one I'm using. Even though this one says theta, it's for any angles that match. So now we're doing it in terms of x. I'm almost done. I have one more thing I can do. What is the sine of x divided by cosine of x? Ooh, I like how you said negative tangent of x, because it's a negative sine of x divided by a positive cosine of x, which is negative tangent of x. That's our final answer. They're not that hard. You just have to know those other minor identities. Last example. 23. We have a cofunction identity for the numerator. If you know what that is going to be equal to, tell the person you're sitting next to. Just for the numerator. If you said sine of x, you are absolutely correct. Now, cosecant of negative x, we have to switch to a positive angle, meaning that I have to take this negative x and it needs to become a positive x, but I have to make a decision. Is it even or is it odd? Let me see. Cosine and secant, its cousin, are even. So that means cosecant is odd. That means that this sine, the sine that is in front, odd, we're going to do the opposite. The opposite is a negative value. Once you get here, I would not write cosecant in the denominator. I'd probably push this thing up. And I have a negative cosecant of x. But if I push that up, cosecant in the denominator is the same thing as sine of x in the numerator. And I'm going to just move this negative up right here too, because a positive divided by a negative is a negative. I can do that. Sine of x times sine of x is sine squared of x, and it's negative for our answer for 23. There are your two examples. I'm going to end your notes right there.